Polynomial long division. This guy here, in blue, is a polynomial, and actually so is this guy in black, 2x minus 3. Polynomial is a word that means many terms. Terms are things that are added together. Here we add the 4x to the fifth plus a negative 10x to the fourth plus 17x squared minus 23. Because there's things that are being added and subtracted, we call this guy a polynomial. And because there's 1, 2, 3, 4 of them, we would say that there's 4 terms in that polynomial. Over here, this guy's also a polynomial, and there's a 2x and a negative 3. And because there's 2 of them, we call this guy a binomial. So anyways, let's get going with the division. We'd like to see how many times 2x minus 3 goes into this. And the way that we're going to go about doing it is a lot like we would have done long division with just plain old numbers. So before I get started with the polynomials, let's refresh our memory about how to divide using long division with numbers. Let's say we want to divide 378 by 16. You might recall we try to figure out how many times 16 goes into 37. We don't try to figure out how many times 16 goes into 378, not right away. And we might realize that we could put 16 into 37 twice, so that gets us 32. And hopefully you recall, after we get that 32, we then subtract. 37 minus 32 gets us 5. Now, we don't try to figure out how many times 16 goes into 5. We first drop down the 8 because we want to get the next digit involved. And then we say, how many times does 16 go into 58? Well, in this case, it looks like about 3 times. 3 times 16 gets us 48. And once again we subtract, and we end up with 10. Now, since we have no other numbers, we could put decimals in, but let's say that we just wanted to end with a fraction of an answer for our remainder. This 10 is the remainder, but we put it over 16 and we add that on to 23. And in case you weren't aware of it, 23 and 10/16 is, and I know that can be reduced, is exactly the same as 23 plus 10/16. Okay, so in the end we can add the remainder on, or we can just write it all as one number. Let's see how this applies over here to polynomial division. So the first thing we're going to do is try to figure out how many times 2x goes into 4x to the fifth power. We're not going to try to figure out how many times 2x minus 3 goes into anything else. Oh, and there's something that I just noticed. We cannot even begin to do polynomial long division until we fix something up. See how my highest power in my polynomial that I'm dividing is a 5? Okay, so I can see that I have x to the fifth, x to the fourth, x to the second, and then I've got just a number. Well, in order for me to do polynomial long division, I'm missing a few things. I need something else. I need to put in placeholders where in place of the x cubed, which is not here, and in place of the x to the first power, which is missing, and that's it. So I cannot do this division unless I have all the powers. And again, in case you're not totally following me, since the highest power is 5, I need to have x to the fifth, x to the fourth, x to the third, x to the second, x to the first. And this guy right here, the 23, is really considered negative 23 times x to the 0 power. So in order to be able to divide, I need to have an x to the fifth, an x to the fourth, x to the third, x to the second, x to the first, and x to the 0. If any of those are missing, I must put them in with zeros. So let's see how that looks. Okay, so I have taken the time to put in a 0x cubed in between this x to the fourth and x squared, and I put in a 0 times x to the first power in between this x squared and this x to the 0 power. I'd like you to pause the video and take a moment and get caught up to me and write this out nice and neat. Okay, once you've done that, we'll begin to divide. Again, I'm going to try to figure out how many times 2x goes into 4x to the fifth. So I know that 2 times 2 is 4, so that's easy. But then what times x gets me x to the fifth? I'm hopeful that you believe that that will be x to the fourth power. Let's see here. So then 2x to the fourth times 2x gets us 4x to the fifth. And then 2x to the fourth times negative 3 gets us negative 6x to the fourth. And then we can go ahead and we can subtract. Now, when you go to subtract, I want to remind you that you're subtracting both things. Just like over here, we're subtracting the 3 and the 2, okay? So we're going to subtract both of these guys. So 4x to the fifth minus 4x to the fifth, that's just 0. It just goes away. And that was our goal. The next thing is negative 10x to the fourth minus negative 6x to the fourth. I strongly recommend that you take some time and you write this off to the side. Do it so that you don't make a silly mistake. It's going to be essentially minus 10 minus negative 6. And don't forget, we'll add the x to the fourth on in a second. And this is the same as negative 10 plus 6. If you take the time to write it out like this, it's going to be very difficult for you to make a mistake. This will get us negative 4. And so what I'm going to do is I'm going to write down here that our result is going to be negative 4x to the fourth. Now, I have to say to myself, what times 2x will get me negative 4x to the fourth? And this time it's going to be negative 2. Negative 2 times 2 gets me negative 4. And then what times x gets me x to the fourth? Hopefully you believe that that's going to be x to the third power. All right. Then we still have to multiply the negative 2x cubed times the negative 3. So, before we do that, we're going to drop down the 0x cubed right here. Let's not forget that. So plus 0x cubed. There we go. Okay, now what we're going to do is we're going to multiply negative 2x cubed times 2x. And when we do, we get negative 4x to the fourth. In other words, negative 2 times 2 is negative 4. X cubed times x is x to the fourth. Then we multiply negative 2x cubed times negative 3. So that gets us plus 6x cubed. And then we will go again and we'll subtract that out. So we take both those guys and we subtract. And again, it's going to be 0 minus 6. If you write that off to the side, it's harder to get it wrong. And that'll leave us with negative 6x cubed. We drop the 17x squared plus 17x squared. And then we can go ahead and figure out what do we multiply times 2x to get negative 6x cubed. So again, probably negative 3. Negative 3 times 2 gets us negative 6. Yay. Then what times x gets me x cubed? X squared. So that'll be x cubed. And then I still have to multiply the negative 3x squared times the negative 3. Just like when I was here, I had to multiply the 2 times times everything, the 1 and the 6, to get 32. And the same with 3, I had to multiply times the 1 and the 6. Anyways, negative 3x squared times negative 3 gets us plus 9x squared. And we will go ahead and subtract, just like we did before. And when we do, we get 17 minus 9. So that'll be positive 8x squared. And then we drop the 0x. There we go. And now we can do the next multiplication. All right, so now we say what times 2x gets me 8x squared. Hopefully you believe that is going to be plus 4. 4 times 2 is 8. And then what times x gets us x squared. So again, hopefully you believe that's just x. So we get 8x squared when we multiply 4x times 2x, then we multiply 4x times -3, and we do minus 12x. And then again, we'll subtract. This process just keeps going. And again, don't forget it's 0 minus a -12. Wouldn't hurt to write that off to the side. And if you do, it's likely that you won't make a mistake. So that'll get us positive 12x. And then we still got to do minus 23. You do not need to write the x to the 0 power. I just wanted to make it really clear that we go 5, 4, 3, 2, 1, 0, or we're doing something wrong. Okay, so let's get back at it. What times 2x gets us 12x? That'll be plus 6. 6 times 2x is 12x. And then 6 times -3 is -18. And again, we need to subtract. -23 minus -18. Write it off to the side. -23 minus -18. That's the same as -23 plus 18. That gets me -5. So we end up with a -5 down here. And since we ran out of terms, x to the 0 is our final term, this must be the remainder. And the way we write the remainder is we do the same thing we did over here with numbers. We take this number 10 and put it over 16. We take this -5 and we put it over 2x minus 3. So we can actually pull that negative sign out in front and just make it into a minus 5. We'll make it into a minus 5 over 2x minus 3. So there's a lot of interesting things in this example. This example would actually be a good problem to try again on your own by yourself several times. If you could nail this one example down, you would know a lot about polynomial long division. Remember that you have to put in the placeholder zeros to make sure that we have all the intermediate powers from the highest power down to 0. You'd be able to practice all the steps, you'd be able to practice your basic arithmetic, and you'd be able to practice what happens when you get a remainder. Now, sometimes when we do polynomial long division, you'll get a 0 down here. And if you get a 0 down here, that means there is no fraction on the end. And then we get a really cool result. If the remainder is 0, then what we have determined is 2x minus 3, well, whatever you're dividing by, we would say then is a factor of this polynomial. So in other words, polynomial long division is a form of factoring. If you get a 0 down here, then we would say that whatever we're dividing by is a factor of whatever we're dividing. And again, you would end up with no remainder if there was a 0 down there. Okay, that's polynomial long division. Practice this problem several times over. If you can, you will be the master.